Hot diggity dog, you were put in charge of marketing at the local minor league baseball park, and you need to decide who your target audience is going to be. Are you going to be marketing towards the children of the community, or are you going to be putting stuff out there trying to get all the adults to come out and watch those baseball games? So what we have here is a word problem. It's going to be a systems of equations word problem, meaning you're going to have to write out two equations and try and solve the solution so that you have more information provided to you. Okay, where do we use system of equations in the real world? This would be the exact idea behind it. Okay, I'm going to read this word problem out. What you and I are going to do is come up with equations to write out, and then we'll solve them just like we would on any of my other videos that I've posted using either the substitution method, the graphing method, or the elimination method. All right, let's get started. A baseball park brings in 88 fans and makes $553 in revenue from ticket sales. Okay, I would stop right then and there, just like I would in most word problems. I'm not going to read the whole thing right off the bat. I'm going to take in what I know. Okay, I might jot down some notes over here of what I've just read. We know that there was a total of 88 fans. So 88 people showed up that night, which right now, if you're in charge of marketing, you're a little worried. That's not a big group coming out to watch that baseball game. Now, if you were the starting pitcher and you didn't have a good night, you're okay with that low number. You made $553. That was also a total. So our totals right now are 553 and 88. One talking about revenue while one is talking about ticket sales or people in seats. Okay, let's read on. A child ticket costs $4 and an adult ticket costs $7. We're now talking about two separate things. We got children tickets and adult tickets, both with different values. Okay, how many of each ticket was sold? Okay. So what we're going to have to do is we're going to have to write our two equations out. Now, if I'm looking at this information, I'm reading through these problems, one thing that is very clear to me is we were trying to find children tickets and adult tickets sold, how many of each. So we're talking about two completely different things with two completely different values, and we're also being given totals. So the first thing that should pop in your head is that we are probably going to write these equations out in what's called standard form. Standard form would look like this: AX plus BY equals C. And I apologize for the pen that I'm using, not really standing out very well. I'm going to grab a new one. Okay, AX plus BY equals C. So that is the form in which I'm going to write these equations out in, because we're talking about two completely different things and a total. So I'm going to give my brackets for a system. And now I'm going to think about what my two equations should be. Now my first equation should be very basic, very simple. We're talking about children tickets. Let's represent that with an X. So X represents child tickets, while Y represents adult tickets. Now, if you really like to have your information match the variable you're using, by all means, use a C for child and an A for adult. That's your choice. I personally, I'm more of a fan of the X and Y. I'm just so used to it. To each their own. Okay, so here we go. We're going to have an amount of children and an amount of adults. We don't know how many of each, but we do know when we put them together, we have a grand total of 88. Okay, hopefully that makes sense. However many children, an unknown, a variable, plus however many adults, again, an unknown, is going to equal a grand total of 88. We do know that. Now, we also have a different price for each one of these, so we want to attach that price as a coefficient to each of the variables, a number attached to the variable, and we're going to give our grand total in cost, $553. Okay, so let's go into how to do that. Children tickets, remember X, and it's a good thing you have your key over here. X represents children, and we know children tickets cost $4. So we're going to say 4X plus $7 for adult tickets, 7Y equals a grand total of 553. We now have our two equations written out, and what it is time to do is solve them. Okay, now before we solve them, take a second, take a breather. You've done a lot of work already. Which method are you choosing to use here. You have three options. You could graph, you could substitute, or you could eliminate. I want you to take a second, think it out, and see if you come up with the same plan as me. If you don't, it doesn't mean your plan is wrong. It just means you may be taking a route that would be trickier than the other. Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and Cracker Jacks. I don't care if I ever get back, for it's root for the Mariners. They don't win, it's a shame, for it's 1, 2, 3 strikes, you're out at the old ball game. All right, hopefully you've come up with your plan. I have mine. I'm going to be using what's called the elimination method. And I can get there very quickly by just making a match. Right now I have an x and a 4x. It doesn't match at this point in time. I have a y and a 7y. Does not match at this time. But if I multiply the top equation all by 4, using the distributive property, I will get a brand new equation that will have a matching 4x on top and bottom. So let's do that now. 4 times x would give me 4x. 4 times y, 4y, and 4 times 88, 80 times 4 is 320, plus another 32 would give me 352. I would double check something like this on my own calculator if I was doing this in class. Doesn't mean you can't do it mentally. It's just always check with your calculator. If you're provided one, it does not hurt. Now copy all of this down below. Plus 7y equals 553. And I have to look at these and notice that they are the exact same. The only way to eliminate a 4x and a 4x is through subtraction. So I'm going to draw that subtraction symbol, draw my bar underneath, and I'm going to subtract straight down now. So I'm going to say 4x minus 4x, and I'm going to say they are gone. See you later. Strike 3. 4 minus 7. I'm going to end up in the negatives there. That's going to give me a negative 3y. And 352 minus 553 would give me negative 201. Okay? Negative 201. So now I'm going to take my negative 3 and divide. Divide by negative 3 on the other side. I'd be left with y equals 67, and it's a positive 67 because we have a negative divided by a negative. And so I know that y is equal to 67, which if I'm covering it up right here, it's hidden, but the second I move, we now know that y represents what? That's right, adults, okay? And we know y is equal to 67, so how many adults went to the ballpark that night? 67 of them. Okay? Now if I take this 67 and I put it right up there into this equation, I know there had to be 88 people at the ballpark that night, 67 of which were adults. That would leave how many children? And your answer would be 21. 21 plus 67 would give me a grand total of 88. So you can now answer as the marketer for this ballpark. You can say we have far more adults going to our ballpark than we do children. This might help you in your marketing scheme, what you're going to be going out and doing as far as marketing to the community. Okay, things that you need to be thinking about, you now have answers to. All right, 67 adults. And 21 children. Hopefully this makes sense to you. Trickiest part about a word problem really is coming up with this, pulling the information out of it and making it into a problem like you typically would see in a math class before you get into word problems. Okay, hopefully you understand this. If you have questions, please leave them in the comments. Hope that you guys all do well on your upcoming systems test.